Hi, I am R. Venkatesh, Assistant Professor in Department of Electronics and Communication Engineering at Rohini College of Engineering and Technology, Anchigramam, Palkulam, Kanyakumari District. Now we are going to see a topic in optical communication system at this LED configuration. After the completion of this topic, student will be able to explain about the basic concept of surface emitting LED configuration and the light source materials in optical fiber. Now we are going to see the introduction part of optical light source. Optical source. What is an optical source? An optical source are the active components whose fundamental function is to convert an electrical energy into optical energy, that is light signal, in an effective manner. Hence, the optical source are called as a transducers. The optical signals is then launched or coupled into an optical fiber. The optical source is the major components in an optical transmitter unit. The popularly used optical sources are light emitting diode LED and semiconductor laser diode, that is injection laser diode ILD. Why you are using LED and lasers are needed in optical communication means the LED and lasers are required in optical fiber transmission system as a light source because it is a compact size, high efficiency, good reliability, light and correct wavelength range. Due to the adequate output power for a wide range and small emissive area compatible with fiber core dimension and the possibility of the direction modulation, that is there the optical output power can be directly modulated by varying the input current at relatively high frequency. So for these reasons, we are considering LED and laser as an optical light source. So in an optical fiber link, the source power should be coupled into fiber with minimum coupling losses. Similarly, the power transfer from one fiber to another fiber and the fiber to detector should be done with maximum coupling efficiency. So, in the optical light source, three major part will be considered. So one is radiance are referred as brightness, emission response time, and high quantum efficiency. So the LED or laser should be used in the fiber transmission applications. It should have high radiance output of brightness and it have produced fast emission response time and it should have a high quantum efficiency. Radiance or otherwise referred as brightness. It is a measure of optical power radiated into an unit solid angle per unit area of an emitting surface. The unit of radiance or power is referred as watt. High radiance are required to couple sufficiently high optical power level into a fiber. Response time. It is a time delay between the application of a current pulse and its representative of optical emission. This time delay is the factor limiting the bandwidth with which the source can be modulated directly by varying the injected current. High quantum efficiency. It is related to the function of electron hole pairs that recombine radially. So now we are going to see the light LED configuration of the light source of optical fiber. Before going to the LED configuration, LED should provide high radiance and high quantum efficiency. It must achieve a carrier and optical confinement process. A carrier confinement is used to achieve a high level of radiative recombination in the active region of the devices, which yield a high quantum efficiency. So, an optical confinement is used for preventing absorption of the emitted radiation by the material surrounding the PN junction process. Here, two different types of junction structures are used. One is heterojunction structure and another one is double heterodyne structure. The homo structure is referred as the structure was to used etched with a gallium arsenic substrate in order to prevent heavy absorption of the emitted radiation and physically to the accommodated to the fiber. So in the double heterodyne structure, the double heterodyne structure is giving increased efficiency from electric and optical confinement as well as less absorption in the emitted radiation. Surface emitting LED. So it is a one of the configuration which is present in the LED configuration. Surface emitting LED, these type of LEDs are needed where data rate is excess of 100 megabits per second at their requirement level. In surface emitting LED, the plane of active light emitting region will be always perpendicular to the fiber axis. It's the pictorial representation of the surface emitting LED. In the surface emitting LED, it is a double heterojunction based structure and the plane of active region is perpendicular to the axis of the fiber. At the top of the diode, double heterojunction is grown on a N-type substrate by gallium arsenic. A circular wall is etched through the substrate of the devices. The fiber is connected to absorb the emitting light. At the back side of the region, a gold coated heat sink is placed to reduce the heat absorption which present in the active region. Now the current is flow through the P-type material on the circular metal contact wall. By this, a small circular active region is indents to produce the beam of light at the center of the active region. Then an isotropic emission pattern which gives by the Lombardian pattern by this process. So, by the use of Lombardian pattern, the source is equally bright when viewed from all direction. So, the emission from the active layer is essentially isotropic one. Through the external emission distributions may be considered as a Lombardian pattern with a beam width of 120-degree angle, and it is referred as half power beam with a thickness of 2.5 micrometer thick. So, the structure of the high radiance is etched well. Double heterostructure emitted 0.8 to 0.9 micrometer. The internal absorption of these devices is very low due to large band gap of confining layer, and the reflection coefficient at the back crystal face is high given to good forward radiances. When a wall is etched in the substrate of gallium arsenic, it is to avoid heavy absorption of the emitted radiations at the back of the active region, the gold coated heat sink, and the fiber is then connected to absorb the emitting light. The circular active area is practical surface emitter in normally 50 micrometer in the diameter and 2.5 micrometer in thickness. The emission pattern of the isotropic width is 120-degree angle with half power beam width. So for intense, the additional of epoxy resin is etched wall tends to reduce the refractive index mismatch and increase the external power efficiency of the devices. The radiation pattern decides the light coupling efficiency of an fiber or the light source. Due to the absorption, some losses will be occur in the active region. Thank you.